question 2. If you missed the first question, please quickly go there now and watch the first question. Watch the question 1 before watching question 2. Solve the given initial value problem using the method of Laplace transform. And we have the differential equation, which is homogeneous. This is second order differential equation. Let's go straight to the solution. Okay, step 1, take Laplace of the differential equation. Take Laplace of the equation. That's step 1. So, and this implies the Laplace of second differential will give you this minus this. That's the Laplace of second differential. Laplace of first differential, your minus is there, open your brackets. Then Laplace of first differential is this. Close the brackets. Then plus Laplace of this, that will be 2. Laplace of what? Of 1 equal to what? Laplace of 0 is 0. So that's what we have now. Then the next thing to do is to begin to substitute the criteria given. This is what? This one is minus 2, and this is what? 5. This one is 5. This is minus 2. Just note that. We can factorize the Laplace is here. Laplace is here. Laplace is here. Let's factorize that. It's minus 2 times this one. That's what? Plus 2s. Okay? Then here, minus what? Minus 5. Then here, we have minus 2 times this, becoming plus times this. So that's what? Minus that, minus 2 equal to 0. Okay? So we now have this Laplace of 1 equal to, can you move this one to other, and then minus 5, minus 2, that's minus 7. Move, take it to that side, that's plus 7. So we can make the Laplace the subjects, and if we do that, we have this over okay. So what we can do now, let's check the denominator. Can we factorize the denominator? The factors of 2 factors of 2 that can generate minus 1. That will be minus 2 plus 1. Okay? So we can factorize it. So this will be, take 1 here, pair it. Okay? Minus 2 plus what? Plus 1. So we can factorize it. So the denominator can be expressed as what? As a product of linear factor, 2 linear factors. And then if you check, you realize that the numerator is of power 1 and the denominator is what? Is of power 2. So in that case now, that calls for partial fraction. Okay? So before we can find the inverse Laplace, we need to do the partial fraction aspects. Okay? Take this one and solve this. Take this and solve this, which is equal to what? Using partial fraction, a over s minus 2 plus b over x plus 1. Then multiply through by the common factor, which is this. Okay? If you do that for the left hand side, we have this plus 7. For the right hand side, that will be a. This and this can cancel. Then we have x plus 1. And then plus b times what? X minus 2. So this is what we have now. Then we can use substitutions to solve this equation so that we can get value for a, value for b. Okay, so let's x be equal to minus 1 so that this expression will go, then we can get b. And that will be equal to minus 2 times minus 1, that's 2, plus what? Plus 7, that's 9, equal to here. This is what? Minus 1 minus minus 2, that's minus 3 b. So b is equal to what? Minus 3. So we can also substitute for x equal to 2. So let's x be 2. Okay, so in that case now we're going to have minus 2 times 2 plus 7 equal to a 2 plus 1 3. So this will be minus 4 plus 7 3 equals what? 3a. So a is what? A is 1. Then we can come back here and do the final step by taking inverse of this, and this one already as an expression. Take the inverse of this, take the inverse of this, and need the inverse Laplace of this, And if you do that for this one, that will be y as a function of t. Because the moment you take your inverse Laplace, you are turning or you are converting from x domain to time domain. Okay, that will be equal to what? Inverse of this expression, and this expression has this. This expression has been turned to partial fraction, which is a, and a is 1 over what? Over x minus 2, and then plus b. B is minus 3 over x plus 1. Okay? So that's what we have. So on the final conclusion, this will be equal to what? Exponential 2t, to exponential to power 2t, then plus times minus, that's 3. Then for sake of explanation, I'm going to turn this one to 1 over x minus 1. Okay? So then I'll have this minus 3 exponential minus t. So that's I just make this one to conform to the standard table. The standard table is inverse Laplace of 1 over x minus a, and that will be equal to exponential to power 80. Okay, that's what we have done. Our a is what? Minus 1. Okay, so that's that on this question. If you're new on this channel or you are yet to subscribe, there is an icon on the video. Please click on that and subscribe so that you can keep track of the updates of this channel. Finally, share this video, share the links on your social media platform. Okay, thank you for doing that. And join the next question 3, on initial value problem using method of Laplace transform.